We previously mentioned segmentation, but I didn't give particularly good examples. So I'm going to go through some simple examples of typical classical segmentation algorithms. So if you remember, segmentation was labeling each pixel as either being something of interest or not. So in this example here, I've downloaded a CT scan of someone's head from Embody 3D. So I want to label each pixel as either belonging to a certain tissue type or not. So in this example, we're going to do thresholding. So here we go. This is in MITK Workbench. I'm going to create a new segmentation. Let's just call it skull. I say OK. You'll then see in this segmentation plugin, there's a range of tools. So the first one we're going to cover is thresholding. I click on the thresholding button and I see a single parameter called threshold. And you'll see that the current value is 1029. If I move this slider down, you see more pixels in green. So green means it has, that is the segmentation value. And as it goes higher, I see fewer green pixels. So if we look slightly more closely now, let's set a threshold value of, I don't know, let's go for 300. What this is doing is quite simply saying anything that is less than 300, we'll just call it background. Anything that is 300 or more, we'll call it segmented, or we will label it with a foreground label. So in this case, 0 is background and 1 is foreground. So if I go confirm segmentation, MITK generates this label image where 0 corresponds to background and 1 corresponds to things that were above the threshold. You have to remember with thresholding that the algorithm has no concept of what it is thresholding. It is entirely looking at pixel values. So whilst I, as a human being, and I know what I'm doing, I'm tempted to call this bone or skull or give it some kind of meaning. From an algorithmic point of view, all of these things are just pixels. Things that were below the threshold have now been labelled in this label image as 0. Things that are above the threshold have been labelled as 1. I can just demonstrate that these are two separate images. If I turn the segmentation off, you can just see the original CT scan, or I can turn this image on, the binary image, and turn the grayscale thing off. So here you can see I now have an image in 3D where pixels have been labelled as 0 for background. If you'll notice in the status bar, when my cursor is over the background, it says the pixel value is 0, and what is now red is a pixel value of 1. Similarly, in addition, I can also say from this binary volume, create me a smooth polygonal model. And here I get one of these typical mesh data sets that we've seen in the graphics lecture, which is generated then from the binary volume. So what we can see then is in this image and in CT scans in general, thresholding is quite good for picking things out as long as they have an intensity range that is what you want, or it's unique enough such that one threshold value will work. There's no cleverness to the algorithm. It doesn't know that one pixel connected to another means anything. It's literally just applying a simple mathematical formula. If it's below the threshold, label the pixel as 0. If it's greater than or equal to the threshold, label it as 1. And that is basic thresholding.